Oh, okay. Let me give you an introduction. Okay, this is Douglas. Okay, like I said before, CFI cadet. So the purpose of this part is to let him practice to teach. And the last section of your weather theory yesterday is about the weather hazard, and he's going to help us to cover this part. Okay, so yep, I'm going to let him take control.
Thank you. Hello, I'm Douglas, and today we're gonna talk about the weather hazard. And there's three main parts. One is the thunderstorm, turbulence, and icy. And let us beginning with a video. This one.
Off on the horizon, they rumble. Rolling across the land, they darken the skies to then spark fire in the darkness, letting out an unmistakable roar. Thunderstorms are rain showers accompanied by lightning and thunder. While violent, these weather phenomena are common, with about 2,000 occurring at any moment worldwide. There are four major types of thunderstorms: single cell, which are small, weak, and isolated storms; multi-cell, a common type of storm that includes a cluster of thunderstorms; squall line, a collection of storms that can form a line hundreds of miles long; and supercells, the most intense kind of storm capable of producing tornadoes. All thunderstorms form when warm air in the lowest layers of the atmosphere rises. Called an updraft, this air causes water from the Earth's surface to evaporate and carries the moisture upward to form clouds. The clouds then build and grow, sometimes as tall as 10 miles high. The clouds darken as they fill and become heavy with water. Cool, dry air from the upper layers of the atmosphere, known as a downdraft, then pull this moisture downward, causing it to fall as life-sustaining rain. In addition to helping sustain life, thunderstorms also help maintain the planet's balance of energy and electricity. When energy, specifically in the form of heat, causes water to evaporate, the heat is carried upward with the water vapor. As the vapor condenses and forms water droplets, it releases the heat into the higher altitudes of the atmosphere and cools the Earth's surface. Thunderstorms also help regulate the electrical balance between the atmosphere and the planet. As clouds in a thunderstorm develop, excess positive and negative charges form within them. At a certain point, this buildup of opposite charges leads to the transfer of electrons in the form of lightning. This transference of electricity occurs so quickly that it breaks the sound barrier, a phenomenon that produces thunder. While thunderstorms are necessary for maintaining balance in the atmosphere, they can also be hazardous. Lightning strikes create fires. Excessive rainfall can cause flash flooding, and high-speed winds from tornadoes can destroy homes. Meteorologists study weather systems to try to predict the occurrence.
Okay. So for the thunderstorm, actually, there's a little bit different to the clouds, because for the thunderstorm, it's kind of like dramatically, like if you have, let's see, if you, for example, for the cloud to rain, like the water vapor to up the air and then condense and just raining full. But if the energy is too much, there's a lot of moisture and then a lot of uplift, and it will create a thunderstorm. So there is a three kind of condition for the thunderstorm to build up. One is the moisture, the water vapor, and unstable air, and outlift. So if there is no moisture, only the uplift and unstable air, even you have just pretty strong updraft, it will not create a thunderstorm. And if there is no outlet, only the water vapor and unstable air, it might just become a cloud. They will not form a thunderstorm. And if there is only water vapor and outlet, it will just the water vapor just come to become vapor from the surface and then to the outside of the air. So it will not, if there is no unstable air condition, they will not even become a cloud because your water vapor will not condense. So there's three kind of condition for the thunderstorm. So only these three things come together, you will become a thunderstorm. One is the water vapor, the moisture, and the unstable air condition, and the lift. So if one of the condition being taken out, they will be the thunderstorm will not form. And let's talk about the type of the thunderstorm. There are three types of the thunderstorm. They will have the single cell, multi-cell, and the super cell. For the thunderstorm, if the thunderstorm just only one forming, because maybe because the atmosphere condition, like only during the summer of the afternoon in the summer, because the sun is heating the surface, and also we have the moisture and uplift, and inside of unstable air condition, it will only create one cell, the single cell of the thunderstorm. But if there is other big weather condition, for example, like cold front, just like we mentioned this yesterday about the cold front, sometimes will create severe weather because the cold front will lift up the because when the cold front is moving pretty fast, it gonna shut up the air mass in front of it. And this kind of, sometimes if the air in front of it have the moisture and pretty heat, they have the moisture and unstable condition. And with this front uplift, it will create a line of the thunderstorm, and it could be the multi-cell. And sometimes during the hot summer, because the pretty the heating from the sun, they will create a supercell. So let's let you guys to see there's three types, and this one is single cell, or we can call it one cell. It's only the one one thunderstorm at this area, and this one is the multi-cell. You can see compared to the single cell just only one, just pretty single and alone. And but for the multi-cell, you can see in here, the right side and the left side, there's kind of like different weather condition, and this kind of cold front, I remember this is kind of like cold front condition, and move forward to lift up the heat and moisture and air to lift up, then this create a multi-cell thunderstorm. And also this this kind of multi-cell, because it's kind of like a chain. Like at the beginning, when this is a cold front, and this is only the heat of hot air moisture at the beginning. If this is okay, so if this is cold front and this is the hot air, okay, so if this kind of cold front just moving forward from the right side to the left side, because the cold front is more dense, right? And then when you just move forward, it will lift off the hot air to the top. So at the beginning, the hot air being lifted up from the surface, and it will become towering cumulus. And then things getting bigger and the lift higher, it will become merger stage and have a lot of thunders, shower rain, and then go to dissipating. So this kind of multi-cell is it will happen at the same time. You can see the towering TCU and thunderstorm merger stage and dissipating stage at the same time. Just like this kind of picture. Like at the beginning here part is kind of like a towering stage, and then maybe around I cannot cut it, but around this part will be the merger stage, and the inside, the another side is already in the dissipating stage. So the multi-cell is kind of like more dramatically conditioned. Will be thunderstorm just forming and become merger stage and dissipating at the same time. And then, and also, if during the pretty hot summer and a pretty strong uplift, because for the thunderstorm, if we because at the beginning we have three kind of condition: moisture, unstable air, and uplift. If the weather is become pretty hot and uplift is pretty strong, so for the weather, it would accumulate a lot of moisture up the air and then become bigger and bigger. If the uplift is pretty strong, even will create a supercell of a thunderstorm. It is pretty big and huge thunderstorm, and it can create more severe weather. And let's talk about the life cycle of the thunderstorm. The thunderstorm have three kind of stage. One is the towering cumulus stage, one is the merger stage, one is the dissipating stage. Each stage have different symptoms. So it's kind of like okay. So for the thunderstorm become forming, like it's just at the beginning, at the surface, it's just a moisture. Just some moisture at the ground, right here. So if there is any uplift, will let this kind of moisture to come upside, to go upside. So there's maybe this is kind of the front, cold front, or the maybe because of the mountain, or because we are at a hot summer afternoon and the surface have been heating by the sun for a long time, so they will have a updraft. Then this kind of updraft will let this kind of moisture become move to the top. And so at the beginning, the moisture being lift up and getting to towering, to getting bigger and bigger. So this is at the beginning of the thunderstorm. Is at the towering cumulus stage. Is when the thunderstorm is getting more energy, getting more heat, getting more moisture, is accumulating the energy. And so this is the first stage. The first stage is the towering TCU, the towering cumulus stage. Will have most of the wind will be the updraft, because right now we just want to lift off all the moisture to the sky. And when this kind of this at the sky, the moisture is too much, and if the air becomes condensed, they'll become water droplet or ice inside of the cloud. And this kind of this kind of water will become bigger and bigger inside of the cloud and become heavier. And since our outlet cannot hold this kind of water or moisture, it will become it will fall from the ground to the ground. So if the uplift, the updraft cannot hold all of the moisture, all of the water, it will fall to the ground. And but since the uplift condition is still on it, so this will call for the uplift cannot hold the water droplet and then will fall from to the ground, and this will become the merger stage. The symptom of the merger stage is that we will have a wind shear, because because if our aircraft just fly over the thunderstorm, it will at the beginning you will face the uplift, but when you go to the this side, there will have a downwash, because this kind of water droplet is too heavy, so our thunderstorm cannot hold it, so it just downdraft to fall to the ground, and this will create a pretty strong downdraft. So the updraft and the downdraft will create a wind shear, because the wind, they will have a big wind difference for the updraft and the downdraft. And so for the mature stage, the most important symptom is there will be have a wind shear and the precipitation. Precipitation is including the raining or snowing or even hail. If the water droplet have become ice and pretty big ice and then just fall from the sky, it will become a hail. And since this kind of water just drop from the sky and then will cooling down, this will cooling down the surface because at the beginning maybe the surface having heating by the sun, but since our water droplet has going down and will cooling the surface, and this will take over the outlet, so this will not exist and will become dissipating stage. Is most of the wind become downdraft, and since there is no air or moisture to the thunderstorm, so there it is no charge from the energy. So this kind of cloud will getting smaller and smaller and smaller and dissipating. So for the dissipating stage is most of the wind is the downdraft, and because the downdraft was shipping this kind of energy back to the ground, and then at the end will this kind of thunderstorm will dissipate. This is the three stage of the thunderstorm. And as maybe play some video and understand simple parts. Okay, this is life cycle.
Now, any thunderstorm can be broken up into three distinct stages. From an academic standpoint, this is very clear and simple to understand. From a realistic standpoint, a large storm can easily be going through multiple stages. And from a realistic standpoint, a large storm can easily be going through multiple stages at the same time, or different parts and pieces of it can be experiencing different stages at the same time. We'll look at an example of that here in just a moment. But first, these three key distinct stages are the towering cumulus stage. This is stage one, where you have very strong updrafts that can exceed 3,000 feet per minute. So this is best explained as a bubble of warm rising air that leaves a cloudy trail in its wake. So you get that towering cumulus stage, the very tall cumulus cloud forming. That is most of the updrafts, and again, up to 3,000 feet per minute, very strong updrafts. The next stage is the mature stage, and this is when rain begins to fall at the surface, all right? So now there's a little bit of rain falling from the cloud. That means that rain falling is going to drag some air down with it, so you get that cool air falling to the bottom of the cloud, so you now have updrafts and some downdrafts during the mature stage. The mature stage is characterized key by the beginning of precipitation at the surface. So as soon as precipitation reaches the surface, that would be the mature stage. And then finally, you have the dissipating stage. This is characterized mostly by downdrafts, very strong downdrafts. And the downdrafts are so strong, in fact, that they kind of cancel out any updrafts or any rising air. So that forces the precipitation to taper off, because those downdrafts are so strong coming down, it allows no other warm, moist air to rise, so you cannot keep feeding the storm. Thus, you wind up with the precipitation eventually trailing off and stopping. So that is the dissipating stage. Mostly downdrafts, very substantial downdrafts, up to speeds of 6,000 feet per minute. Now in reality here we can see where this general area, all right, so you can call it one storm, you can call it multiple storms, whatever you want to call it, this general area near the airport here, we can see where we have updrafts and downdrafts happening at the same time. So this could be called the mature stage really, but ultimately you have the cumulus stage, you have things still building, you have parts of the storm building, and then you have sort of a mature stage in this area where you have some downdrafts, Mostly updrafts though right now because
Oh, sorry. So for here, this is kind of thunderstorm is forming at the beginning stage. But as you see here, it's kind of like downdraft. So maybe previously maybe this is had another thunderstorm and this is at this peaking stage. And so the thunderstorm can be not just one forming at an area, maybe we'll have different, I mean, like more than one thunderstorm create at the same area. So each thunderstorm may be at a different stage. Maybe this one is at a cumulus stage and mature stage and dissipating stage. So it actually the thunderstorm for us in Taiwan because our weather is quite common in Taiwan, especially in Taitung during the summertime. It will be pretty hot. There will be a lot of thunderstorm. So for the thunderstorm, why we need to start in this kind of topic? There is a few reasons. First reason is that thunderstorm will create a lot of hazard. For example, like for the for here, they will have a wind shear between the mature stage. If your aircraft is flying through the mature stage at the updraft part, because you think you want to level fly, and then you think your aircraft is living off, so may bless you, maybe you will want to, because you want to level fly, so you'll reduce the power, reduce the speed to back to original altitude. But since you passing the updraft part to the downdraft part, this downdraft part will let you drop to the ground. So at these parts, you need to increase your power pretty quickly. Otherwise, your aircraft will fall down to the ground. So it's pretty severe. It's pretty dangerous for our aircraft. And not only this one, also because the thunderstorm, like inside of thunderstorm, they have a lot of updraft and downdraft. And if your aircraft just fly through the thunderstorm, like cumulus stage or whichever, just inside of thunderstorm, because inside there have a lot of updraft, downdraft, and a lot of moisture they are mixing. And when your aircraft just fly through it, will have severe turbulence, will not only vibrating your aircraft, but also might damage to your structure. And besides this, the thunderstorm will create the lightning, the hail, and even the tornado. So for the lightning parts, this will actually, in the history of the inside of the history of the airplane, like there is only the simple severe accident because of lightning, because our aircraft have been designed can be hold for the lightning, but the lightning also will affect to our equipment, because lightning is pretty strong energy. It will affect to our navigation system and the communication system. If we fly near to the lightning, because this kind of strong energy will create magnet, and this kind of magnet and electricity will affect to our navigation system and also communication. So if you fly nearby the thunderstorm which have lightning, you might get into a lost condition, or you might get lost if you are flying in IFR, because your navigation system be affected by the lightning. And another more severe part is the hail. The hail is just like a ice ball, and if because our aircraft flying pretty fast, right? We have for actually our DA-40 or DA-42 only 120 knots or even 150 knots. But for the commercial aircraft, they'll fly pretty fast, like more than 200 knots. And if there is a hail, ice, just in front of it, and the aircraft, the ice hits to the aircraft, it will damage our aircraft, and yeah, will also the damage to the equipment of the aircraft. This can be pretty severe to our aircraft. And not only this one, but also if the thunderstorm updraft is pretty strong, it also can create a tornado. And for a tornado, actually because the tornado will create during the merger stage, the cumulus stage and the merger stage. So tornado will not hold pretty long time, but because that is a pretty strong updraft, it will create pretty strong, it will destroy a lot of stuff and will become pretty danger if you've been sucked up this to the ground. So it also can be pretty danger. And so as I mentioned, the thunderstorm, the danger of a thunderstorm, not only the main parts of the thunderstorm, but also there is the area nearby the thunderstorm will also be affected. For example, like here, because maybe here's part is at a dissipating stage, and this is maybe the smooth air. So when your aircraft just flying from here, the weather is pretty fine and it's pretty nice and pretty smooth, and then you just fly until you reach the downdraft part. You'll suddenly drop because you are inside of the downdraft part, and this, even if you are not pretty close to a thunderstorm, this area can be affected by the thunderstorm. And if your aircraft is in the downwind side of the thunderstorm, for example, your aircraft is like here, and in here, this is the L shape of the thunderstorm. So inside here, actually, they are accumulating a lot of water droplet and even some hail inside of it. So if this cumulus stage cannot hold it, it will become a downdraft. And this kind of water droplet or the ice will fall down, and you was here. So it will hit your aircraft. So even you are not in the area of the main area of the thunderstorm, you still can be affected by the thunderstorm. So because of so for our regulation or our book, they have mentioned to prevent we into the affected area from the thunderstorm, we need to stay away around 20 nautical miles from the thunderstorm. So if you find out. Okay, this is your aircraft. And you just want to fly to here. You go through it. But in here, the weather radar tell you here have a thunderstorm. So you might to stay away from it. To this side or this side to go through it. And we should be aware, stay away from the thunderstorm around 29 per mile. Because this kind of area will still be affected by the thunderstorm. Maybe the wind shear will also affect to this kind of area within 29 per mile. Or if there is an ample cloud, there will be a hill around surrounding this area. So, and also maybe inside of the thunderstorm, we have a lining inside. Lining inside. This will affect your navigation equipment or communication equipment. Will let you get into a lost condition or lost calm condition. So, just be aware to stay away from the thunderstorm. But if there is more than 2 thunderstorms nearby you or inside of your flight path, your design flight path, like maybe in here is pretty close, like maybe 1.59 miles. And maybe here have a mountain. It's not realistic to maybe in here have a mountain or other boundary you cannot go through. So you cannot stay away 29 miles from the thunderstorm. The best way is to cancel your mission, to head it back, because you don't want maybe you don't want to just fly through it and get into a very severe condition, then you cannot hold it. Or if there is necessary to go through it, you can go to the upwind side. If the wind is from this side, then you can go on the left side to go through it. But you still need to stay away from the thunderstorm as far as possible, because the close to the thunderstorm, the severe effective from the thunderstorm will be. And if you flying in the sky, there is like flying here. Okay, so in here, like this originally, this is a cumulus stage of a thunderstorm being created like this shape, right? But because there will have a strong wind, so that's why some of cloud being moved from the left, the center of the thunderstorm to the right side. So if we see an envelope cloud, we can roughly to know where is the wind direction around this area. So if we are flying the aircraft, we will choose to fly to the left side, not to the right side. because there's two reasons. One, because this is upwind side. So most of the thunderstorm activity were not that close to the upwind side. But to the downwind side, here have an envelope cloud, here have a hill, or maybe because the strong wind also moving this kind of thunderstorm to the right side. And when you fly through, maybe before you fly through it, you think, oh, it will not move to your flight path. But when you are flying through it, because the wind just move this kind of thunderstorm to your side, and you were into the thunderstorm, just fly right into the thunderstorm, and it will affect you. So if necessary, you need to go through it. It's better to go through it in the upwind side, not to a downwind side. Is that okay for a thunderstorm? Okay. Let's talk about the turbulence.哦，我要休息一下。
看你自己，
对。
或是你可以50分的时候再休息，或是休息几分钟什么，或者多看自己。
Okay. Or we can take a break for 10 minutes, and I'm going to turbulence later.
没有，我走眼啊，背好痒。
想说，因为我自己也没有教课，所以我写出来其实
没有关系，
不一定是
这个东西就是互相的，应该这样讲，没有绝对对与错，但是这个过程当中，大家就是在错误中学习，所以最后可以说，哦，他或许有你喜欢的东西。
我昨天念完的那个，
有这个建议，
昨天念这个书，
他愿意听，那就是他愿意听，他不愿意听就没关系。
因为懂你。
飞行员是互相帮忙这个义务。
这是什么？应该是 aerodynamics 是吧？昨天念完 aerodynamics。
那时候跟你进入一样，我也是念完就学了1个月的那个，
毕竟这个东西，
因为选120几，看了你的话
120几条。
120、160我忘记了。
我要讲点后
对自己，
哪有白痴都这样。
我刚刚讲到 squall line， 我刚刚有讲到 squall line， 没有讲到波折，你讲波折好，那就这样。
没有。我在说那个super cell 的事情。 多危险？很多危险的部分吗？比如说这个，这个。哦，这个好像他们有一点一个吸进去，然后让它甩出来。哦，这个的话确实这个很专业，这个有危险。也是，但是你在这种说明方面的话，真的危险，所以你要注意听。好的，我想一想。哎，这个是。Let's talk about turbulence. For the low level, low level, we have three kind of turbulence: mechanical turbulence, convective turbulence, and frontal turbulence. Mechanical turbulence is that when, for example, in here, this is a runway, and maybe in here has some facility, for example, like the tower, or our hangar, or the terminal. And when this is a building or an obstacle, and this is a wing. On the left side to the right side. And if there's no obstacle, the wing will go through it pretty smoothly, right? But since you have a building or some obstacle, will force this kind of wing to the outside to flew over it. And when go to the go through it, because in this area, there have no wing to through it from here to here. So this will create a vibration, a vortex or a turbulence inside this small area. And if this kind of obstacle is pretty big and the wing is pretty heavy, pretty strong, and in here maybe is our runway paving. So this because the wing is pretty strong and this obstacle is pretty big, this affected area can affect to our runway and affect to our aircraft. This is the mechanical turbulence. So it's because this the reason for mechanical turbulence is the wing being blocked or being affected by the obstacle. Not only the hand of the building will affect it, but also in our textbook they also mention information about if there is a valley, they also will affect to the wind, and this kind of vortex or vibration will create a turbulence, and this cause the mechanical turbulence. And I will tell you about our condition in our Phongnian airport later. Okay. And another thing is convective turbulence. It's during the summertime or maybe at a noon at a service. Okay, at a service. At a service, because the sun is hitting the surface, and also hitting the air surrounding this area. And when the heat is more much, and you will create a small thermal. It's not the moisture, but it's kind of like a hot air just being leveled from the surface to up the sky, and so will be small thermal, just kind of like transition the energy from the surface to up to the sky. And when your aircraft is fly through this kind of thermal, will let you feel the turbulence. And another thing is the frontal turbulence. So for the front, especially the fast moving cold front, because is it a cold front? When they're moving, they also will live off some of the air. Let off the air. And this kind of living force will also create a turbulence. So this is the frontal turbulence. And inside of, for our Phongnian airport, because, okay, can you see? Okay. In here, this is our runway, and this is our hangar, and this is the terminal, the building. The building is over here. And if there is pretty strong wind from the right side to the left side, go through this kind of building here. The building is over here. The wind, because it cannot pass the building directly, so the wind will go surround it or fly over it, and this kind of surrounding air, surrounding wind will create some of the turbulence. So if the wind, that's why they still have some distance from the runway. If this terminal is pretty close to the runway, this runway can be affected by the mechanical turbulence. Yeah. Okay. And also, we have a hangar here, but hangar is not that big. Terminal is bigger, if there is a mechanical turbulence, might be just a small one. Okay. So another turbulence, the convective turbulence, this will affect to your flight most. Is when we are flying. Sorry, Jimmy, did we mention about the traffic pattern before?
Yes.
Okay, so especially we doing the traffic pattern parts. Our traffic pattern, the aircraft traffic pattern. Basically, we'll do, this is the upwind and crosswind, downwind. Sometimes we'll to go to Taidong Daxue, and then base leg, and final. Okay, so especially for the river bed, because there is no tree, and this is only the dust or just a rock, and this can be heating by the sun pretty easily. And so in here, especially during the noon, like or the afternoon, this kind of river band will be heating by the sun and will create some thermal. And this kind of thermal will affect to your flight. And for example, if especially when you are doing the final, because you are descending, it's kind of like condition is like this one. You are, for example, in here maybe it's a runway, and we are approaching. So we want to land, but there are some thermal just lift you up. So right this condition, you need to reduce your power to keep inside of the flight path or guide slope. So, or you're gonna fly over the runway. So in especially for the summertime or the afternoon, because the surface have been heating by the sun, there will be a lot of thermal, and sometimes pretty hard to control during the final. But after you passing the riverband, will surrounding this area, because there are a lot of farm there, so the thermal will be not that strong. So maybe for our flight, the affected area might just surrounding the riverband will be the most. And if you fly through it, just stable your aircraft, and when you fly through it, it will back to the normal. Yeah. This also will, this kind of convective turbulence will affect to our aircraft control. Okay. Then let's talk about wet turbulence. So as you guys know, when the aircraft flying, the wingtip will have a wingtip vortex, right? And this, this kind of wingtip vortex is also a turbulence. So when our aircraft just fly through it, this kind of wingtip vortex will create a turbulence. And what if our aircraft is incidentally fly into of this kind of turbulence area? Your aircraft were being like affected, maybe bang to the right or bang to the left, or even because the wet turbulence, the wingtip vortex is from the upside to the downside, maybe your aircraft will be shipping down, whichever is possible. And not only this one, but also helicopter will have wet turbulence. So this is when after a helicopter flying through it and there is another Cessna just flying nearby it and being affected by the wake turbulence of the helicopter. You see, helicopter fly through it and yeah. So this in here the helicopter just fly through the runway from left side to the right side, right? But because and also even you cannot see anything, the wake turbulence still exists. And this kind of Cessna aircraft just want to fly, just landing. And when during their landing, have been affected by the wake turbulence of the helicopter. So, yeah. Being flip up. Yeah.
Douglas?
Yes.
So how long was this wake turbulence disappear?
Okay. So, oh wait a second. So for avoiding for the wet turbulence parts, we need to wait for 2 minutes because you know turbulence, this kind of turbulence is kind of like vortex, and also it just created by the aircraft, right? So after aircraft fly through it, it will not extinct for pretty long time. So generally, if just 2 minutes is enough. But for the aircraft, because this wave turbulence is created by the wind vortex, if this aircraft is pretty heavy and in a clean configuration and flying pretty slow, the windy vortex will be a pretty big one. And so in this kind of condition, you might need to wait more than 2 minutes. But the general idea is fly after it for 2 minutes. If a light aircraft, because it's pretty light, it seems the same, but yeah, a small aircraft, because the lift requirement is pretty is not that much, so only create a few windy vortex. So if there's only small one, the wave turbulence will be only small one, and it will not extend pretty long. But for the big aircraft, the larger aircraft, it will extend pretty long time. And there is another part, as for the helicopter, because inside of our Honian aerodrome, we also have helicopter operation surrounding us. So it's better to stay away 3 times of rotor diameter. It's like this one. If you see the helicopter is holding inside this area, there surround 3 diameter of the helicopter will be also this kind of this air will also, or this place will also be affected by the helicopter also. So if you see there's especially during the daytime, they also have a training. So if possible, we would like to wait until they pass for 2 minutes and we will landing or taxi. So just be as way as possible. Yeah, because for the helicopter, they also will create weight turbulence. And because our aircraft is pretty light, and it's pretty easy to be put up from the weight turbulence. Yeah. Okay. And if it's necessary to go through it, for example, when you are doing a traffic pattern, you're already in the final, and you already turn into the base, and then tower just tell you, or ATR, just take off, and be aware of weight turbulence. What can you do? Because you're already almost at the base or the final. You are approaching, and it's compared to the takeoff time, it's less than 2 minutes. So the way to avoid it is, if you are landing, for example, if you got a landing and they already take off, just stay away from their flight path. So yeah, maybe takeoff run is here, and they just live up here. Then basically you can land here. But you're gonna do a touch and go, right? So it's they just take off here, and you need to rotate and take off before them. Otherwise, you're inside of their weight turbulence area. Weight turbulence is around here. So if you fly, if you lay off or take off after that, you fly through here, you'll get into the weight turbulence area. And it's pretty dangerous. So it's better to take off before approaching, and then touch and go, and reload before their takeoff area. And if there's another condition. If they're ATR aircraft, just then if they're ATR, just land here. Because the weight turbulence will still exist during this area, right? And you will not want it to go through it, or you'll get into the weight turbulence area. It will be very dangerous. So it's better to touch down after their touchdown zone, and this will let you stay away from their weight turbulence area. Yeah, this is only in case you cannot wait for more than 2 minutes until dissipating of the weight turbulence. Yeah.
So, yeah, turbulence there. So when you are taking off at the airline,
Mm-hmm.
for example, there's a 737. Their engine is more powerful than us, so their climb rate could be more around us, like
Yeah.
1,000 or 2,000 feet per minute. And
Yeah.
he says EA40 I can only climb for 650 feet per minute.
Mhm.
So the ankle or they were deeper and we were just better.
Yeah.
So if we climb out at a normal rate, and we would just hit it turbulent, right?
Yeah. So so there's just like I mentioned about, like, we can wait for 2 minutes maybe. If we had a downwind or upwind or crosswind, just request and hold at the downwind side or some part to wait for 2 minutes, then to landing or takeoff. And if it's next, like we are approaching and they just take off, just as you know, because they are heavier and their speed will be faster. So the accelerate distance will be longer. So they might need to wait. This is a runway. Okay, this is a runway. Maybe end of runway here. They might need this kind of long of a runway to take off, right? Yeah. And because we are lighter, so maybe we just need this kind of area that can take off. And then since we take off,
their takeoff angle will be deeper than us,
Yeah.
and our engine isn't that powerful to do that deep takeoff. So
yeah, so we after
So we-
our leave off, I mean before this one, before we reaching their flight path, we can turn. Okay, we can turn to a down request early crosswind. We can turn earlier. So like this one, they just take off it around here, right? The flight path may be like this one, but because we are lighter, we can just take off around here. And after takeoff, we know because of our climb rate is not as great as them. But we can do what we can do. We can turn earlier before them, right?
yeah, that
So
that will
can-
require the special request from
Yeah.
5.5 ATC, right?
Yeah. So that's why I mentioned about we can request early crosswind to be aware. I mean, stay away from the wet turbulence. So this is possible for us. I mean, but you know, for the best way, if you are on the ground, and you just saw ATR or a big aircraft, just take off, just stay on the ground wait for 2 minutes. 2 minutes is not a big deal for you, but just I say, if you are at a final and you need to do a touch and go, so it's better to, I mean, like lay off and then turn before you reaching their flight path. Yeah. Okay. Any question? Okay.
When an aircraft is flying, is there still the wake turbulence behind?
You mean our aircraft or?
Yeah, with the big one,
Yeah. I mean,
when they are flying.
so there is a.
Well, compared to the tank aircraft, our turbine will be
Very
very
Yeah.
small than compared to them, so it very affected.
Yes, but still have. I mean, yeah, because our aircraft is pretty small and even there have the wet turbulence, it will not extend pretty long time. So it's okay for them to depart after us. Like after we take off, we go ahead, okay, clear ATR clear for takeoff, Mandarin clear for takeoff, and they don't care about the wet turbulence we create because we are pretty light. Even I have a wet turbulence is pretty light for them because they are bigger and they are powerful. It's okay for them. And as you see, when I think this is already takeoff, they have a windy vortex, and this kind of windy vortex is that on the runway is also called the wet turbulence. Yeah. So you see, after the flight through it, the windy vortex still exists for a while. Yeah. They say it's when an aircraft is going to landing. And as you see, surrounding this area, we have a windy vortex, and also this will become a wet turbulence to affect our aircraft. see these two effect area? Yeah, so it will affect to aircraft also. Okay, let's back to. Okay. So the general idea for that is to stay 2 minutes after they take off or landing. And let's talk about the clear air turbulence. The clear air turbulence is a turbulence which hard to see, and because this kind of clear air turbulence is not created by the thunderstorm or other weather phenomenon. It is created, most of the clear air turbulence is created by a jet stream, and jet stream is pretty. I mean, compared to the weather phenomenon, there's no visible moisture. You can identify where is it. So that's why even in the commercial aircraft, sometimes they still incidentally fly through a clear air turbulence because you cannot see where is the turbulence area. And because this kind of clear air turbulence is created by the jet stream, and jet stream is pretty powerful wind, and it will also create pretty powerful turbulence also. Okay, let's talk about wind shear and microbursts. Okay. Basically, they have this kind of microburst will create by the thunderstorm. If there's a thunderstorm cloud here, over this area, and in the merger stage or the dissipating stage, they will have lots of downdraft. And when this kind of downdraft hitting the surface, it will change the wind direction. If this kind of downdraft hitting here, hitting the ground, will be change the distance, maybe to the upside or go through it, and in here, it will go downside and go right out. And in here, just some downdraft. Okay, imagine that if your aircraft just being taken off from the airfield right here, and then you want to take off, we will maintain the speed like 72, and then suddenly there's a strong headwind to us, so and also have a lot up you have updraft, so your aircraft might be lift up and pretty fast. So you think this is too fast, might be effect to your aircraft. So you might just slow down or just level earlier and then fly through it. Then to here, you being into the downdraft area. And because this is pretty strong downdraft, it will let you just fall pretty quickly. And then when you fly through it, you become a tailwind condition, and you'll lose your speed, and then go into stall. Sorry, there's another part I need to mention in here. So. If our aircraft, for example, our aircraft is takeoff, because we just take off, and then we just pretty slow, and we want to have a high AOA because we need more lift, right? But if we go through this area and let its wing direction to this to here, this will become greater AOA. And this color. This will be greater AOA. So maybe you will get into the stall because your AOA is getting the because you are inside of the critical AOA. So and also you are at a low altitude and a low speed. So even they give you some outlet, but because the increase of AOA and you might need to you might get into the critical AOA and then stall in during the takeoff. Okay. And then if we are approaching, we are doing landing surrounding a microburst area. Because our aircraft, we are descending. Okay? Because we are descend, we want to follow this kind of glide path to here. This is our airfield. It's over here. And when we just stable and approach everything things pretty nice and go through here, there's a pretty strong downdraft. And we was flying through this flight path because this downdraft will be dropped from the sky. So we need to increase the power suddenly to go through it and go back to the original flight path. It's like this one. Our aircraft is flying to here, and everything is pretty nice and stable. And because we inside of effective area of the microburst, and this is a downdraft, and then just suddenly drop. And if we did not effect quickly, our aircraft could be full before reaching the runway. And even we pass through it, we increase the power and then try to stable, like downside and try to stable here. But in here, there has a strong tailwind. Then it means like the relating wing getting pretty small, and when we are going to landing, we will have fly in pretty slow speed, and it's possible to stall and fall before we reach the runway. So if there is a thunderstorm nearby the airfield, like especially inside of the flight path, not only the upwind side, but also the final side, it's possible to not just fly through it because they might have a microburst surrounding this kind of area. Okay. Also, this kind of microburst or thunderstorm will cause the wind shear. The wind shear is the wind change in the small area, and because the direction of the wind is quite different, then if your aircraft just flying to here to the upside, then right now maybe you're having the wind from the right side, so you're just heading to the right and go through it and suddenly to the left side. Then this kind of condition will let you need to control, like shift your control pretty quickly, and it's hard to hold it because inside they also have a shear zone, and this is kind of turbulence area because this is the area merged between two kind of air, two kind of wind, and not only bumpy but also will let you hard to control your aircraft. Yeah, this is a wind shear. But what if this kind of wind direction change, not only the side wave, but also the uplift and the downdraft? This will be pretty dangerous if you should fly. You think you're right now because you're on the updraft side, and then you just think, okay, I'm stable to climb, but suddenly you, because the wind shear, you just into the downdraft part, then your aircraft could be fall pretty fast. This is the wind shear. Anything about turbulence? Okay.
So flying inside a microburst, so the thing is not to decrease your power and keep it stable or even add it.
Okay, so for the microburst part, this ideally just like the wave turbulence part, just not to get into this kind of area. But maybe inside of some kind of condition, you really need to go through it. Maybe you are around the field or something like you want to pee or other things, you need to land immediately. So it's better with your aircraft with the high power setting, the maximum condenser power, and then stable your aircraft until you passing through this kind of microburst. And actually there's another general idea for microburst, because microburst is one of like one of the symptoms of the thunderstorm, and the microburst will not hold pretty long because this is almost like dissipating stage of the thunderstorm, right? So the thunderstorm is dissipating, so maybe around 20 minutes or 30 minutes the microburst will come off and you can land safely.
So if this is clear turbulent situation, you don't know that,
Yeah.
and you just fly it on for you and complete you just add more power.
Yeah, I mean, like if you are in the clear air turbulence, it's hard to expect you gotta fly through it. If you know there's a turbulence, you would like to stay away from it, right?
Yeah.
You don't want the bumpy or hard to control your aircraft. So if you just instantly fly through the turbulence area, you just there's two kinds of conditions. If you are in the microburst, because you know they will have a pretty strong downdraft, so you need to increase your power and try to stable your aircraft. But if you up the air, like you still have a lot of altitude, and you are inside of turbulence area, and because this kind of turbulence will not only bumpy but also will let your aircraft banking or pitch out, pitch down. And this, if you fly your aircraft in high speed, this might damage to your aircraft structure. So the things we will do is reduce the speed to the VO or maneuver speed. That's reduced because also the suddenly change of the wind, and then it will shift the turbulence will also that's the aircraft loading, G loading getting bigger, and this might over the G loading weaken our capacity. So we just reduce the speed to VO or maneuver speed, then go through it. Because you know the turbulence will not hold pretty long, or you just try to stay away from them. Just maintain the VO, and after fly through it, back to normal. It will not be a big deal. But yeah, so there's two two things required. If you're up the air, inside of turbulence, maintain the VO renewal speed, and then just fly through it, or stay away from it. Try to get away from it. But if almost approaching to landing part, yeah, also be stay away from that. But if necessary, you need to go through it. Just maintain the high power setting, and then maybe do the high speed approach to reduce the effective by the microburst or other low level turbulence. Okay, any question so far? Okay. Do you guys need to take another break before I mention another topic? I see.
You're PIC.
I'm a PIC. Okay. Let's take a 5-minute break, short break, and then come back with the IC card. Almost finished.
Douglas，中午吃什么？
Well, wait for the 水煮。好，你们要吃什么？
我去买那个什么72度。
然后看那花方茶汤，然后每包礼拜几都会有特价，那汉堡蛮好吃的。
哎呦，哎呦，
因为它都写在它的板上面。
你说那个特价的时候啊？
对，然后不知道礼拜3还是礼拜几，我忘记，它有时候会换日子。
妈呀，就是人太少的时候吸引大家去，然后去吃这边72度 C 舒肥健康餐。
哦，健康耶。我先把我的强心吃。
先吃你的健康餐。
对啊，快结束了。下个礼拜去体检。
那我说上课感觉如何？
我觉得我脚好慢。
一刚开始一颗心扑通的，
有一点点。
你比较稳。
然后我有发现我脚
前面声音有颤抖。
真的。
前面感觉是你在颤抖，但是你压抑住颤抖。
哦。
所以就讲比较慢。
我就想说，我会不会讲话讲太快，然后大家没有时间思考？
你回去看录影就知道了。
哎呀，好嘞，剩下的事情我会速速解决。
速。
So it will become heavy and heavy. So especially for our small aircraft, we're pretty light. So if there is a big shade or ice on our aircraft, we'll be getting pretty heavy, and it will be maybe it's too weight, too heavy to handle it. We cannot level fly and even drop. So I think it's pretty dangerous for our flying. For the commercial aircraft, they have other de-icing system can go through it, but our aircraft, because we are pretty small aircraft, we're pretty light, we don't have this kind of complicated system to support us. And let me introduce, we have 3 kind of icing. The structure icing is the icing on the wing. The first one is the ram ice. It's like this. It's like a white and milky color of the ice. This is because the super cool water being heat, because the super cool water, it need, like, for the ice to form, we need have 3 conditions, right? One is the moisture, visible moisture. One is the low temperature. One is condensation nuclei. And because the super cool water, they don't have condensation nuclei, and so it will become still a liquid form, right? And if our aircraft just fly through it, we are the condensation nuclei, and it will become forming the icing on our wing. And if we fly through this kind of super cool water, the ice will easy to form on our wing. And and if this kind of if we inside of pretty low temperature, especially for the minus 15 degree to minus 20 degree, and also the moisture is not that much, will become the rim ice. And if the temperature is higher, it's like 0 degree to minus 10 degree, and have a much of moisture, it will become clear ice. If the clear ice is just like the ice you made for the refrigerator, right? It's pretty big, and as you see, compared to the previous one, like this one is pretty rough, and this will affect your airfoil, the creation. It will create a lot of drag and damage, destroy your lift. And the clear ice parts, yeah, is compared to the rim ice pretty smooth, but as you know, this is a big part of air wing, and then also this is a big part of the ice. It's pretty heavy, and also because the clear ice is also forming outside of our wing, also will destroy our lift also, and also is heavy. And the most important things for this one, the clear ice is dangerous than the rim ice, is because in the general idea, the clear ice can be happen in the 0 degree to minus 10 degree, and the rim ice is even lower temperature. So inside of this, if this kind of low temperature, maybe the supercool water is become the ice pretty easily, so it will not sustain on the air for a long time. And even if there's so, the water, the moisture will not that much. But for the clear ice, it will, like, if there's a cumulus cloud, you'll have a lot of water drop that inside of it. And once the supercool water just forming on your aircraft, you will become a lot of water on it, and then create clear ice suddenly. And this will, compared to the rim ice, is more dangerous for your aircraft, because the first is the ice, the quantity of the ice is pretty much, and forming pretty fast, and also it can create the higher temperature compared to the rim ice. And also there's another condition is called the mixed ice. It's not only have the rim ice but also the clear ice coming together. And this ice condition is because this will affect to our outside of our aircraft, so we call it structure icing. So this kind of structure icing not only just will forming on the wing, but also will forming at our elevator and the rudder and even the aero. So because this is our control surface, what if this kind of ice just forming at the joint of our control surface? They will let you cannot control your aircraft, because you want, maybe because you are inside of the icing condition, you want to pitch up. For a pitch up, you need to let your elevator to going up, right? But because here has the ice here, so if you just pull your stick but because there's ice there, you cannot do it because there have some ice stuck in there. So you might hard to control, even cannot control your aircraft. So be aware not to get into the icing condition. Yeah, for you guys, because after your ground school, you are going to summer season. The weather will get hotter, will not that easy to get into the icing condition. But if there is pretty strong thunderstorm, because they not only have a pretty strong updraft but also pretty strong downdraft. They might shipping the the cold and high the high altitude, the pretty cold air from the top of the thunderstorm, and then they might have the super cool water can drop from the pretty high side to the downside. So there's a possible during the summer. It's like the temperature maybe like 20 degrees, you still get into an icing condition. Yeah. And by the way, beside this kind of structure icing, I believe before that, Jimmy or Ray had instructor Jimmy and instructor Ray might mention about we have other icing condition for the aircraft. Like we have induction icing, the carburetor icing, and air intake icing. Do you guys still remember what I did? Yeah. So actually, for our aircraft, we have 3 types of icing. Is the structure icing. Is the icing which affect to our outside structure of the aircraft. And if this kind of icing will affect to our power plant, our engine, we'll call it the induction icing, like carburetor icing, or even our air intake being, there has a filter in front of it, right? If they're being stuck by the icing, it will also will affect to our power plant. This is the air intake icing. And also there's some pretty sensitive parts for our aircraft. We have pitot tube and steady pole. This also can be blocked by the icing. So if it's the inside of the cold weather condition, we will turn on the pitot heat to prevent the icing forming inside of a pitot tube. So yeah, so this kind of icing will affect to our instrument. It called the instrument icing. Basically, for our aircraft, we have 2 kinds of instrument can be affected by the icing. One is a pitot tube, one is a steady pole. So the best way is to stay away from the icing condition. If you fly in this kind of altitude and you find out, shoot, there is some ice, like red ice, is forming at our wing, then we need to stay away from it. So maybe you need to descend to a low altitude, like the temperature will be greater, so it will be hotter. It's not that easy to form the ice, right? Or we can to change our direction. Maybe in here, maybe this is kind of cumulus cloud. Behind the cumulus cloud, and there's an icing in here. So we might can change the direction to another way, and then can stay away from the icing. So there are different ways to stay away from it. Yeah. But if there's especially if there's icing, because we don't have for DA40 we don't have the icing system for the structure icing. We will not fly during the icing condition. Yeah, because we don't have the de-icing system. Okay. That's all for the icing. And also let's talk about the low visibility parts. Okay. Okay. Up the air. not only the visible moisture will let your visibility going low, cannot see through it, but also if there is any dust or there is some air pollen, I mean like some particle inside the air, or that also that you hard to see through it. For example, if this is should be like Shanghai or someplace because they have a lot of factory, they will produce a lot of air pollution, and this kind of air pollution will let you, because the particle is pretty small, where will stand at the air for a long time, and then it's pretty hard for you to see through it, and this will let you have a low visibility because hard to go through it, to see through it, and so not only the visible moisture, the water or the ice will affect your visibility, but also the particle will affect it, and they have a full kind of phenomenon to affect our visibility. One is the haze and the smoke, smog, and dust. The haze is pretty. You guys know the PM 2.5, the pretty small particle, and because it's pretty small and very light, it's easy to extend the air, and then will affect to your visibility. And because this kind of particle is pretty dry, I mean, there is not moisture requirement for it to extend, right? So this also will this kind of particle called air phenomenon called the haze, because just a low visibility and just some particle, and this will not like if there's no strong wind to remove it, this will extend up the air with low visibility for a while. And another thing is smoke. Smoke, especially for the US, they have a wildfire or inside of, and this will create a lot of smoke. And smoke is not only have the particle of the PM 2.5, like small particle, but also inside they have different kind of gas inside, and also have some chemistry like carbon monoxide, and there are a lot of things mixed together, and compare the smoke compared to haze is that the visibility for smoke is much lower than the haze because it's pretty thin, yeah. And yeah, but the smoke, it won't, because the particle is bigger than, compared to the haze, it's bigger, so it will not sustain in the air for a long time. So maybe after the fire, a few days later, or maybe hours later, the smoke will go. Yeah. And another thing is more dramatically is the smog and the dust. It's pretty understanding for the dust because if you are at a desert area, if there's a pretty strong wind, you will blow and then let the dust on the surface to up the sky, and this will become the dust storm, right? And this will also let you have a low visibility. Okay, for the smog part, what if the haze or smoke inside of mist or fog condition? the moisture and the dry particle mix it together, it will create much lower air condition. And not only this one will let you feel low visibility, and also your aircraft will will getting dirty, but also because they have a lot of different chemistry inside, maybe it will damage for your aircraft for long term. Yeah. And oh, by the way, for the fog and the mist, do you guys still remember what is the difference between the fog and the mist? The visibility difference. For the fog, is the visibility is much lower, is less than 1,000 meter. But if your visibility is more than 1,000 meter, but lower than 5 kilometer, yeah, so it will be called mist. Okay. And the final part, volcano ash. Okay, this is another weather phenomenon. Is if actually in Taiwan is not easy to see, but if you go to the southeast of Asia or inside of Japan's area, sometimes you'll have a volcano eruption, and this will create the volcano ash. And the inside of a volcano ash will have different kind of gas, dust, and ash. And because the volcano eruption is pretty powerful, the dust might not just small as a dust, might can be a bigger, like a big storm of the air, because volcano is pretty powerful. And imagine that this kind of big kind of rocket being just lit off by the volcano, and your aircraft just fly through it. What will happen to your aircraft? It will be a big damage. And besides this one, because the volcano ash, they have a lot of different gas and chemistry inside of it, and not only that, but they also have a small particle and material inside. And if your aircraft just fly through it, you're not only will affect to your structure outside the leading edge or aircraft, but also if this kind of ash being intact to your engine, what will happen? This kind of dust will like stuck your engine, and you're getting engine failure. So in the history, there is a airway being the 747 aircraft being just incidentally fly through a volcano ash, because that was at the night. They cannot see where is the volcano ash, and also it was unexpected volcano eruption, so they just fly through it. And because the volcano will create a lot of dust and ash, and the engine. Okay, the dust and ash being sucked in of the engine, and that the engine have been damaged and stored from the ash, and then 4 of the engine of the 747 have been drained out because of the volcano ash, and this is pretty severe weather. So luckily in Taiwan, especially in Taitung area, we don't have the volcano, but in the future, because you guys would like to fly the international airline, so it's possible to fly nearby the volcano area, and it's better if you can see there's any volcano activity nearby there, just stay away from that. Yeah. And that's all of today.
Do you wanna play the video and show them?
Okay, okay.
Engine for British Airways 747 stopped working.
Roger, declare emergency.
Mayday, 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 free bird now.
With no engines and a little power, British Airways flight June 1982. British Airways Flight 9 cruises through the sky over Indonesia. In a few hours, the plane and all 263 people on board are scheduled to land in Perth, Australia. A little longer.
I've not flown with Eric before, or Barry, and that was the first time we'd actually met on that flight.
As the jet flies over the city of Jakarta, it's cruising at more than 36,000 feet and has been in the air for an hour and a half. Captain Moody checks his weather radar. It shows smooth sailing for the next 300 miles.
All right, Roger, it's all clear. Keep your eyes open. Be back in a moment. Just go use the loo.
Back in the cabin, many of the passengers had fallen asleep. While Charles Capewell and his sons doze,
At the
an
beginning,
ominous haze appears above their
everything
heads.
is quite
It's still
normal, just
visible to smoke on passenger jets in
a
1982.
normal flight,
The
and
cabin
everything
crew,
is
though,
like
the
pretty
smoke
nice and
seems thicker than normal.
smooth, operating everything, just like used to.
They
like
begin to
normal.
worry that a small fire may be smoldering somewhere on the plane.
Maybe some of it up in the toilet. Let's go see if we can find it.
A fire at 36,000 feet is a terrifying prospect. If there is a blaze somewhere, the crew must find it immediately. In the cockpit, the flight takes an unsettling turn.
Barry and I were just sitting there minding the shop. Pitch dark night, of course, and then we started to get these pinpricks of light on the windscreen.
Is it Elmo's fire?
I don't think so. It's not moving the way it should.
St. Elmo's fire is a natural phenomenon that's sometimes seen when planes fly through hot H.
This is kind of like a spatial phenomenon for the there. Okay, so there's lots in here. In the windshield, sometimes if you are inside of the thunderstorm, because maybe there is the inside of the thunderstorm or the cloud, they have electric. I mean, like negative or positive, but it's not that strong as like create the lightning. But they still want to deliver from a negative place to the right, the positive part. So sometimes they will just the electric or through the aircraft body to just to the other side. And when this happen to our aircraft, and it will create the nose fire. And not only the aircraft will have this kind of phenomenon, but also the ship will have this kind of phenomenon. And they will mention this later. Yeah. But this for the condition they face right now is a little bit different to the Samus fire.
Charged thunderclouds, but there aren't supposed to be any thunderclouds tonight.
Anything on the radar?
No. No, it's clear. I don't like the look of this.
And
Let's get a better look
they
out there.
look at the radar because they thought maybe there
With the
is
help of the landing lights, It's
thunderstorm in
really
front of
disturbed
them,
to see a
but the
familiar
radar
cloud
just
surrounding
only
their
can
plane,
detect
even though
the
nothing is showing
moisture.
up on their radar.
But the volcano ash is pretty dry probably.
Will be high
It's
cirrus,
hard to detect.
which is just a
so
thin
there's
layer of
nothing.
cloud.
I think we better get the captain back up here.
I was reading in my book, and there was a slight flick of turbulence, just a slight flick, and I glanced over to the left, where I had a clear view of the port wing, and to my surprise, it was covered in a brilliant white, shimmering light, which seemed to be clinging to the wing of the aircraft. I carried on reading.
晶莹多粉面润肉，含双效养护锁水配方，养出水嫩 Q 弹美肌。我即是你，你亦是我，你约炮某种感受。
But I found that I kept reading the same paragraph over and over again and not taking in a word of it. I just didn't know what was happening.
In the cabin, the smoke begins to thicken. Stewards have been unable to figure out where it's coming from. If there's a fire, they can't find it.
All right, go see that the passengers are comfortable.
I noticed that thick smoke was pouring into the cabin through the vents above the windows. And that was a very sobering sight.
Turkish cigarettes.
It smelled like the sort of sulfuric electrical smell. And I went on that flight deck expecting to hear that we had some electrical smoke somewhere on the aircraft.
Just remember the smoke. And
Good
we
start.
are.
Or just after you stepped out. Anything on radar? No, it's clear, not a cloud.
Yeah, they are not in.
Oh my lord, look at engine 4! It's lit up somehow. Captain, have a look at number 1.
It's the same on my side.
None of the crew have ever seen anything like this before, but the light show is just the beginning. Their bizarre flight is about to take a terrifying turn for the worse.
This light show, if you like, it became more intense. In fact, we ended up sitting there with 2 sheets of brilliant white light in front of us in place of the windscreens.
Inside the cabin, smoke has been growing thicker. Chief Steward Graham Skinner has been organizing an intense but quiet search for fire.
What's with all the smoke?
There was smoke in the cabin, it got really, really hot. They were perspiring, literally drenched in perspiration. The acrid smoke was at the back of your throat, up your nose, in your eyes, and you're rubbing this and your eyes are running, and it was not a very nice situation at all.
Flight engineer Barry Tumley Freeman has been checking his instruments carefully. He smelled the smoke, but so far has no indication that there's a fire in any of the plane's systems.
Can't find anything.
With one mystery confronting them, they are suddenly faced with a frightening new situation.
The engine's on fire!
The whole of the wing was a sheet of light. And I thought, wow, I said, oh, we better close that because we don't want to shut.
Cheers. See ya.
The
realise that, something was dramatically wrong.
There were huge flames coming out of the back of the engines. 20, some people said 40 feet long. These huge jets of sheer flame shooting out of the back of all the engines. Is it going to penetrate from the outside of the aircraft? Is it going to come into the cabin? Are we going to burn to death? Are we going to choke to death on the smoke? What's going to happen? What's causing it? What are they going to do about it?
As the fire engulfs the engines, one of them revs loudly and flames out.
Engine failure, number 4.
Fire action, number 4.
Checklist powering gear, set. Thrust lever, closed. Start lever, off.
The engine
Once
have
one
been
engine fails, you
affected by
call for
the
the
volcano
drills to shut
ash,
that one down.
and
You have drills for certain routes, so that you don't fly together as a crew forever. You can fly with different people then, and you can standardise the operations.
The instruments do not indicate a fire in the plane, but the passengers can see flames erupting from the engines and stretching down the length of the 747.
I could not see the engines from where I was sitting. I could only see the space behind them. But there was enough glow in that space to convince me that the aircraft was really seriously on fire.
We were in trouble. They knew, as long as they were, they knew we were in bad trouble. And they sort of just looked at me and looked to say, well, what are we doing now, Dad?
The 747 is more than 6 miles above the ocean. Its engines appear to be burning, and the peculiar smoke continues to fill the cabin. And then the unthinkable happens.
Number 2 engine's gone. All right then, begin the engine shut. No, wait!
这就是麦当劳维切斯起司牌双牛堡，源自母乳启发，会产生春日散。
跟学校要请。
Remember, all 4 engines have failed.
The other 3 just went out almost immediately, and that's when it begins to be a serious emergency.
Those engines made a grating, rumbling sound, almost like a cement mixer.
for a 747, we have 4 engines.
The noise just disappeared and they became
almost
silent.
impossible to
Minute
get
and a half,
into
we've
the
gone from
whole of the
4 engines running normally to
different
having one.
engine out completion. It's
The
almost
747 has plenty of fuel, yet somehow all 4 of the jet's engines have completely stopped working.
Roger, declare emergency.
Mayday, 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 Speedbird 9. We have lost all 4 engines out of 370. Mayday, 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 Speedbird 9. We've lost all 4 engines out of...
With no engine power and no idea what has crippled their plane, British Airways Flight 9 begins falling from the sky.
Okay, let me explain some parts. Okay, so because the aircraft is flying through the volcano ash, and for the air intake for the cabin is taken in from the engine. They like for the commercial aircraft, because there is the pressurized cabin inside of the aircraft, because they gonna fly in a pretty high altitude, and so they need to have the air need to intake and then compress and then put it inside of the cabin. And because they are inside of the volcano ash, and volcano ash, they have a lot of different gas, and also have some ash and the smoke inside of it. So that's why the smoke, even there's no fire inside of aircraft, but there is a smoke outside of aircraft, and this kind of smoke being taken inside of the aircraft they will, yeah, the passenger all feel uncomfortable. And not only this one, but also inside the volcano ash, they have a lot of different particles inside and dust, even material and or metal. And this, because it will damage to the engine, that cause the fall of the engine of the 747 being thrown out. And also not only this one, but also as you see, all the aircraft being like grinding, like getting pretty light because inside of volcanic ash they have a lot of particles, and this is kind of like a grinder to try to how to say just heating to our aircraft, the surface outside of the aircraft body. So that's why the passenger see the inside of cabin, they see the old aircraft just like on the fire because there's a lot of particles just hitting the wing and the surface of the aircraft. And and so this also will damage to our aircraft, but because they stay in this kind of condition not for a pretty long time. But if you stay in the volcano ash in a pretty long time, this might have a severe damage to your aircraft also. Yeah. And there's still time. Let's finish this one.
Jakarta Control, Speedbird 9, we have lost all 4 engines. Now out of 360.
First Officer Roger Greaves issues a mayday, but he has trouble getting his message across.
Have you got a problem? Jakarta Control, Speedbird 9, we have lost all 4 engines. Repeat, all 4 engines. Now descending through flight level 350.
Speedbird 9, you have lost number 4 engine?
This idiot doesn't understand. Jakarta Control, Speedbird 9, we have lost all 4 engines. Repeat, all 4 engines. Now descending through flight level 350.
The air traffic control at Jakarta, unfortunately, seemed to have a slight problem in understanding what we actually were saying.
Only when another plane nearby relays the mayday call do controllers in Jakarta understand.
Now descending through flight level 350.
Speedbird 9, all 4 engines out. Understood. Standing by.
As far as the crew knows, no 747 had ever lost power to all of its engines before. The crew has to find out why it's happening now.
I think we've cocked something up. We were concerned and worried that we'd done something wrong, to cause the whole thing.
All 3 of us felt exactly the same, and it was a personal guilt in the sense of what have I missed, what have I done wrong, because this kind of thing doesn't happen.
While not built for gliding, even without its engines, the 747 can travel forward 9 miles for every half mile it drops. With no power, Flight 9 has started a long, slow fall. Some 6 miles above the ocean, the crew has less than half an hour before they smash into the sea.
When they all stop, you go into automatic mode. Obviously, we had practiced this drill on the simulator many, many times, and that's very good and all very well, as long as when it happens to you for real, what happens on the aeroplane is mirrored by what happens to you in the simulator. And I'm afraid that wasn't so.
In the simulator, when all 4 engines stop, the autopilot turns off. But high above the Indian Ocean, Captain Moody sees that his autopilot is still on.
We were all 3 confused and concerned that what was happening to us wasn't what we'd been told would happen to us.
All right, begin restart drill.
In the heat of the situation, they have no time to figure out why the autopilot is still on.
On. Anything? Anything?
No.
All right then, from the top, battery, check. On. Cross feed valves, open. Fire switch, in.
The The standard restart drill takes up to 3 minutes to complete.
Fuel pressure.
Plunging from the sky, the crew has fewer than 10 chances to get their engines going before they run out of time.
Come on.
Again, gentlemen.
All right, from the top, battery, check. On. Crossfeed valves. Open. Fire switch. In.
At 32,000 feet, Captain Eric Moody decides to turn the plane back toward the closest airport, Halim, just outside Jakarta. But even that is too far away if he can't get at least some of the engines going again.
Jakarta, Speedbird 9, turning left back to Halim, out of 300.
Speedbird 9, radar cannot see you. Squawk Alpha 7700.
Air traffic control asks them to transmit the emergency transponder signal.
Jakarta, Speedbird 9, we are already squawking 7700.
Now the crew is flying back to an airport that can't find them on the radar. Without the constant rumble of the engines, the cabin is quiet. Some of the passengers feel the plane beginning to descend. But without communication from the cockpit, they can only guess.
The quietness was unbelievable, because it was sort of, the airplane has no engines, nothing, and it seemed to be eerie, you know.
Q 弹黄金虾排，层层酸甜滋味，肯德基夏威夷海洋 Q 虾堡。
Lux 香氛沐浴乳，蔷薇与蓝莓酒，全新调酒香魅力登场。
It's surreal, really, because like as if you were suspended in space or something. And I could feel this quietness and a whimpering from a few people that were really upset.
Some people were sitting quite rigidly, almost as if they hadn't noticed anything. At first it was sheer fear, and then after a while it turns to acceptance. You know you're going to die. We knew we were going to die.
Captain Moody can't restart the engines unless he can keep the plane flying between 290 and 310 miles per hour. But the airspeed indicators aren't working.
Captain, I've got 320 knots on my side.
Well, I've got 270.
Bloody hell, it's a 50-knot difference.
I'll change the speed.
Falling from the sky with no engine power, the 747 crew now has no idea how fast they're going. But to have the best chance to restart the engines, Captain Moody has to have the plane flying at the right speed.
So from that point onwards, Eric then varied the speed through just about 100-knot range, hoping that at some point or other, coincidental with us putting the fuel into the engines, that we would actually be at the right speed.
To change speeds, Captain Moody turns the autopilot off. Then he slowly pulls the nose of the jet up to slow it, and then pushes it down to increase his speed. The upsetting roller coaster movement adds to the panic felt in the cabin.
Pressure warning, Captain. We're at 10,000.
Pressure warning? That's not supposed to do that. And a warning horn went off. Now this didn't ever happen on the simulator in this exercise, so it was a bit of a surprise to us.
As well as providing electrical power, the engines on a jumbo jet help keep the cabin pressurized.
With the engines not working, of course, the air wasn't being pumped in. So gradually the pressure was leaking away.
With all 4 engines gone, the pressurized air is rapidly seeping out. The thinning level of oxygen makes passengers gasp. The crew reach for their oxygen masks, but First Officer Greaves can't get his mask to work.
My oxygen mask, was a problem I could have done without. It was stowed above my head, and when I pulled the oxygen mask down, the mask and the tube became separated.
The captain must make a difficult choice. If he continues to descend slowly, it will get increasingly difficult for First Officer Greaves to breathe.
So look, if we get down to 20,000 feet quickly, we can all take our oxygen masks off and we can talk. We're back as a crew again.
We had to actually increase the rate of descent to descend to a lower altitude quicker, which in circumstances was something that we wouldn't really have chosen to do.
So then I dived the aeroplane and got rid of about 6,000 feet in a minute.
The loss of cabin pressure and the steep dive have another terrifying consequence.
The things shot down, they sort of dangled down in front of you. And I looked to see Stephen got his, and Chaz had pulled his out of the socket. So I made sure that Chaz got his oxygen. I've seen a few movies on planes, and you know, once that happens, you know you're in serious trouble.
Help me. What? Dad? Breathe normally, Mum, not deep. Breathe calmly.
The oxygen masks came down.
The cabin crew tries to use the public address system to explain what's going on, but it's not working. Chief Steward Graham's scanner makes do with a low-tech backup.
Can you hear me? We're having a small problem with the public address system. So if you would, place your mask over your mouth and nose and breathe normally.
In the cockpit, First Officer Roger Graves manages to fix his broken oxygen mask, but he's still frustrated by engines that won't start.
All right, let's start the restart drill. Ready? Set. Battery. Check. Off. Standby power. On. Anything? Come on, anything? No. All right, then. Let's from the top. Battery. Check. Off.
First Officer Graves and Engineer Barry Townley Freeman have actually shortened the standard restart drill. It's giving them more chances to get the engines going, but so far, nothing's working.
Come on, you old son.
The process that we were going through the whole time was just continuous. We haven't had any success with the drill at all, despite all the efforts we were putting in. But it was the only thing we had left to cling on to, so that's what we did.
From the top again. Battery. Check. On.
I have no idea, I don't think any of us have, how many times we tried to restart those engines. If I say 20, I would think that's too low. If I say
上午3点，让茶春奶香，完美融合，立顿奶茶。
50, I would think that's probably about right.
As the plane falls lower and lower, Captain Moody faces a brutal choice. A muzzle range cuts across the island just between his plane and the airport. He knows he has to be at least 11,000 feet high to clear it. But if his engines don't restart soon, they won't make it. At this rate, it will crash in a matter of minutes. It's just a question of where. Captain Moody decides if the engines don't restart soon, he'll turn back toward the ocean and try landing on the water.
All right, are you getting something?
It's not starting.
I knew it was so difficult to land aeroplanes on the sea, even when you had everything going for you. And I thought that, well, we haven't got much going.
And they was instantly to flying through volcano ash condition, and so because the volcano ash damaged the aircraft service, the leading edge and all aircraft service, and also the engine. So
Turbofan.
here
A turbofan jet engine works by sucking in enormous amounts of air. The air is then highly pressurized by the engine's compressor. This tightly packed air is mixed with fuel and ignited. The force of this reaction propels the jet through the sky.
The temperature in the combustion chamber where this ash is flowing through are around 2,000 degrees centigrade, 40
per end of the engine.
yeah, so all the engine being stopped by volcano ash and damaged by volcano ash, and so that's why it caused the fan out of the engine failure, and yeah, so but at the end they had restarts parts of the engine. I don't remember, 2 or 1 of the engine. Then they come back safely. So because they have 4 engines, they have 4 chances to do it. So but for our DF40, we only have 1 engine, and also we are pretty light, small aircraft. We have no much. We cannot fly them higher. They don't have that much altitude to lose, to glide, to come back. So if you fly, if you, if there's any volcano ash or volcano activity, just stay away from it. And even the commercial aircraft, they are not designed to go through it. So if even for a commercial aircraft, if they saw there's any volcano ash, then we'll just stay away from it. Okay, and that's all for today.